Welcome to Module 7b from our series on artificial intelligence. The topic of this module is advanced or more advanced PyTorch for image recognition. It will teach us to build a machine learning based image recognition algorithm from scratch via PyTorch. I'd like to begin by asking a question, and that is, can we implement this machine learning example, the one from the previous module, where we want to recognize handwritten digits 0 through 9? Can we do this with fewer than 500 lines of PyTorch code? And the answer is yes, at least for the primary executable script. There are some secondary questions that I'd also like to introduce. The first being, how do we optimally design and structure machine learning software for image recognition in terms of maximizing performance as well as scalability? The second question being, in general, how do we implement more advanced PyTorch-based machine learning projects, more advanced as compared to the Perceptron from module number 6? Third question being, how do different loss functions and optimizers affect machine learning performance? Fourth being, what role does the learning rate, momentum and dampening, as well as weight decay play in machine learning and the success rate of that machine learning algorithm? And then fifth, what is an adaptive learning rate? The focus of this module is explaining Python and PyTorch code. As such, I provide 3 ways that you can download this source code. The first is Google Colab, which is probably the easiest way to access the code. Unfortunately, however, this version doesn't allow you to add new training images nor change the 4x4 sensor grid that we presented in the previous module. You can also access the code from GitHub or my personal Dropbox. For most of this module, we're going to be focusing on the version that is available in the Dropbox. Before we discuss the project structure or the code itself, I did want to take a minute to discuss Google Colab. You can see that I've loaded the Google Colab notebook for this project on my Mac. It's pretty easy to navigate. We can click on the folder icon as well as the content tab, and this shows us all of the files that are available for use by our Python script. Right now, we're missing several important files. In order to rectify that, we can go to the first script, the one that's labeled step number 1, click on the play button, and if we scroll down, we'll see messages telling us that those necessary files are being loaded into the content folder, and we can also see them being brought up over here to the left. So what are these files? The first is the image processing library that we've discussed on several occasions. The other 2 are data files. Now, it would be pretty difficult for us to download hundreds of training images from Google Drive and upload them to the Google Colab content folder. As such, what we've done is use another PC to process those images, vectorize them, and yield the arrays that serve as inputs to the neural network. And this is the reason why when we employ the Google Colab version of this code, we're unable to change the resolution of the 4x4 sensor grid. Once these files are loaded, we can scroll down to the second script, the main script, hit the play button, wait for 1 second here, scroll down a little bit more, and then see the results of our machine learning. You can see here these numbers, 7,500. This is telling us the iteration number. It's telling us error, the optimization method.